Hello everyone. In this lecture we will discuss how IPv4 and IPv6 can coexist, and one of the important things that we already run out IPv4 addresses, and IPv6 in previous lecture we will discuss that offers a much larger IP address spaces. The main goal is to make sure devices using IPv4 and IPv6 can communicate. This is done by method like dual stack, tunneling, and translation techniques. So we will discuss each of them. So first of all, what is dual stack? Dual stack is translation technology where devices operate with both IPv4 and IPv6 protocols at the same time. This allows them to communicate seamlessly with network using either protocol. It is one of the widely adopted methods for enabling IPv4 and IPv6 coexistence. How does it work? Devices are configured with both IPv and IPv4 and IPv6 addresses. So, for example, we have device. Inside of device, we have two protocols. So, if destination supports IPv6, so device uses IPv6 is preferred. If destination is IPv4, IPv4 is used. Dual stack eliminates the need for conversion or encapsulation as both protocols work natively. So one of the advantages, simple implementation, easy to deploy in the network where IPv6 is gradually introduced alongside with IPv4. No conversation need since device handle both protocols at the same time. There is no need for complex packet translating or tunneling. So we have a couple of disadvantages of this. So all devices on network infrastructure, router switches must support both IPv4 and IPv6, which may increase cost and complexity. And running two protocols simultaneously can consume more system and network resources. So use cases ideal for network transition to IPv6 while maintaining compatibility with existing IPv4 infrastructure, common in enterprise network, internet service providers, and data center. So if we overall summarize this one, dual stack is a straightforward and effective method for IPv4 and IPv6 coexistence. It simplifies communicate during the transition period but requires dual support from devices and networks, which can be challenging in older infrastructure. So the next is tunneling. Tunneling is a method to send IPv6 traffic to the existing IPv4 networks. It allows IPv6 packets to travel across networks that do not natively support IPv6 by encapsulating them in IPv header, because we have IPv4, for example, packet. We can encapsulate it and send this traffic using this old infrastructure with encapsulation. So how it does work? So IPv6 packets are wrapped, encapsulated, which I showed inside of IPv4 packets. The IPv network delivers the packets to designated endpoint. At the endpoint, the IPv packet is extracted and forwarded to the IPv6 network when we send back to the next hop. So in here, after delivering IPv6 packet will be encapsulated and delivered to the endpoint. So common tunneling methods is ISATAP, is intrasite automatic tunnel addressing protocol, Teredo, 6/4, and rapid deployment, and NAT64. So I will explain each of them. So the first one is ISATAP. So ISATAP is a tunneling method that allows IPv6 devices to communicate over IPv4 based private network. It creates virtual IPv6 connection with the IPv4 networks, making it is useful tool for organization transition to IPv6. How does it work? ISATAP uses IPv4 network as a link layer for IPv6 communication. IPv6 packets are encapsulated inside IPv packets. For transport, devices automatically generate IPv6 addressing using the IPv4 address and in the ISATAP format. So key feature is automatic address configuration. IPv6 addresses are generated without manual configuration, simplifies the deployment process in private networks. No changes to IPv4 infrastructures. It means works with its existing IPv4 setup. Internal use only. ISATAP is designed for this in private network, not for internet-facing applications. So, for example, if we have a bunch of office, so inside our network we can use ISATAP, but it's not possible to connect another office or branch of office to coexisting. So is it impossible to this? And one couple of advantages reduces the complexity of IPv6 deployment, allows gradual transition to IPv6 without disrupting existing IPv4 infrastructure, no need for additional hardware or major recognition, but disadvantages are limited to internal private networks, does not support NAT, so ISATAP does not support NAT, making is unsuitable for networks with a heavy NAT usage. Best use case transition internal organization networks to IPv4 while maintaining IPv4 infrastructure, ideal for enterprise testing IPv6 deployment or gradually introducing IPv6 to their systems. So overall, ISATAP is a practical tunneling solution for organization needing IPv6 communication with the private IPv4 networks. It automates the setup process, making it a simple, efficient option for internal IPv6 adoption. So the next one is Teredo, is tunneling protocol that allows IPv6 traffic to travel through IPv4 networks even with the NAT. So NAT is network address translation is used, so it is designed for environments like home and small office where NAT is commonly deployed. So how that works? The same as ISATAP. Teredo encapsulates IPv6 packet inside of IPv4, but in this case he used UDP packet. These packets can pass through the NAT-enabled network without requiring special configuration. Teredo's server helps establish the tunnel between IPv6 devices over IPv4. Key features is NAT traversal, one of the few tunnel methods especially designed to work to the NAT. So IPv4 compatibility allows IPv6 traffic over existing IPv4 infrastructure. Advantages are easy to use, work without significant changes to the network or NAT devices, cost effective, no need for new hardware or major reconfiguration. So key disadvantages are performance. One of the performance encapsulation introduces additional overheat, leading to slower performance compared to native IPv6. Teredo reliance on public service and UDP encapsulation can expose network to potential threats, so it's not secure to use Teredo in this case. So best use case is suitable for home or small office network transition to IPv6 where NAT is prevalent, ideal for users who need IPv6 connectivity without immediate upgrades to the infrastructure. So if we summarize, Teredo is convenient tunneling solution for enabling IPv6 NAT heavy environments, while it provides easy way to connect IPv6 devices over IPv4. Its slower performance and security concerns make it a temporary solution during the transition to native IPv6. So the next one is 64, is automatic tunneling mechanism that enables IPv6 packets to travel over IPv4 networks. It uses specific IPv4 addresses to space to create IPv6 addresses, allowing IPv6 communicate without manual configuration. So how it does work? IPv6 addresses are generated automatically from public IPv4 address, encapsulate IPv6 packets inside IPv4 packets for transition over IPv4 networks. 64 relay routers at destination decapsulate the packets and forward them to the IPv6 network. So key features: automatic address configuration, devices generate IPv6 addresses without user intervention, IPv address derived from IPv4 address prefix. For example, here is 2002. We have to use /16 here in IPv6. So advantage: no need manual setup, simplifies the process of enabling IPv4 over IPv6 over IPv4, ideal for temporary or experimental IPv6 use. So in this case, one of the disadvantage is it requires public IPv4 address and cannot be used on private networks with a NAT. So if you have a private network inside Office and you cannot use IPv6 to 4 inside before NAT, you have to use as a public IP address for addresses. Performance can be inconsistent, especially in NAT-heavy environments. So best case is suitable for network with the public 4 addresses. IPv4 addresses transition to IPv6, often used in experimental or temporary IPv6 deployment. So 64 provides a simple, automated way to enable IPv6 over IPv4 networks, while it offers easy to deployment. It relies on public. So 64 reliance on public IPv4 addresses, and challenges with the NAT make it less suitable for long-term or large-scale use. So next one is 6/4. Is tunneling that encapsulates IPv6 packets into multicast traffic. It allows IPv6 devices to communicate with the IPv4 network that supports multicast. So IPv6 packets are encapsulated with IPv4 multicast packets. The IPv4 multicast infrastructure is used to deliver these packets to IPv6 enabled device. Requires IPv4 network to support multicast routing. So one of the necessary facts we have to use multicast routing. So key feature uses IPv4 multicast address to identify rich IPv6 enabled devices, designed for networks where both IPv4 and IPv6 are supported. Advantage: leverage existing IPv4 multicast infrastructure to enable IPv6 communication, efficient in environments where multicast is already implemented, but cons are limited use. IPv4 multicast networks are very rare, so I don't know where we can use IPv4 multicast address, but reducing and applicable of this method. Complex configuration: multicast routing can be challenging to set up and maintain. So best use case: internal networks or experimental setups where IPv4 multicast is already enabled, suitable for specific application requiring multicast communication. So IPv6/4 is specialized tunneling method for IPv6 communication with the multicast enabled IPv4 networks. Although technically effective, it's limited use in modern networks and makes it a rarely adapted solution. So next one, CSRD. So IPv6 rapid deployment is a tunneling method that allows internet service provider to deploy IPv6 over the existing IPv4 infrastructure quickly. It's enhancement of 6/4. but managed directly by the ISP, making it more reliable and effective. So similar as the 624, so IPv6 RD. IPv encapsulates IPv6 packets with the IPv packets for the transport. ISP assign IPv6 prefixes to customers based on their IPv addresses. Unlike 264, the entire process is managed by ISP, ensuring consistency and reliability. And so key features is that ISP control everything, configuration, routing, avoiding the reliability issues of 64. So he knows your IPv4 address. He can assign prefix based on your IPv4 address. So works well with NAT environments, making it suitable for wider range of networks. So advantages: reliability, ISP control ensures better performance compared to public nature of 64. So it's like almost 624. NAT supportive, can function effectively in network with a NAT, unlike 624. So 6RD is the ISP managed tunneling solution for deploying IPv6 over IPv4 efficiently by addressing reliability and NAT limitation of 64. It serves as more robust option for IPv6 transition during early stage of adoption. So the next one is NAT64. It's the same transition method, enables communication between IPv6 only clients when you have only IPv6 client. And you have IPv4 servers. It works by translating IPv6 packets into IPv4 packets and vice versa, allowing networks to operate with the both protocol without requiring dual stack configuration. So IPv clients send a request to NAT64 gateway. The gateway translated these packets into IPv4 packets. IPv4 only server respond, and NAT64 gateway translates the packets back into IPv4 client. So if we go back, receive the answer from IPv4 servers, it's gateway to NAT64, and it's back to IPv6 clients. So domain name server 64 is complementary server, help to resolve IPv4 under server addressing for IPv6 clients. Key features is facilitating communication between IPv6 and IPv4 networks, eliminate the need for dual stack support on end devices, typically used in IPv4 domain networks with legacy IPv4 systems. So its advantage supports IPv4 and IPv6 coexistence, enable IPv6 clients to access IPv4 resources, ensuring compatibility. Reduce the complexity of running dual stack configuration. Disadvantage requires NAT64 gateway, adding a single point of failure and extra configuration. So you have to be careful with this, and sometimes you have to double check of the configuration. Translation introduce additional latency, which can affect performance. Works well with IPv6 clients accessing IPv4 servers, but not other way around. So NAT64 is an effective tool for enabling IPv6 to IPv4 communication during transition phase, while it allows IPv6 only clients to access IPv4 resources. Its reliance on the gateway and added latency make it best suited a temporary solution until IPv6 adoption is completed. So guys, overall we covered a bunch of methods to coexist in IPv6 and IPv4. So one of them will be used on your final practical. Probably it will be I'm sure that NAT64, you have to deeply study this one to be so you can implement this configuration in your final practical. Thank you very much. See you later.